Hello, you guys. It's Lakita from Apex Nursing Academy. Today, we're going to be doing some dosage calculation problems using dimensional analysis. So, if you want to practice along with me, get your pencil, paper, whatever you need, and let's go. A nurse has an order to administer ibuprofen 400 milligram IM. The pharmacy has available a 10 milliliter vial containing 1 gram of the medication. How many milliliters will the nurse administer? So the first thing I do when I'm setting up my dimensional analysis problem is I go straight to the question to find out or repeat, what are they asking me for? They're asking me for how many milliliters? So that's what I start with, milliliters. And I go right into setting up my dimensional analysis problem. I look for, what do we have available? Milliliters, 10 milliliter vial containing 1 gram. I put that right into my problem, 10 milliliters to 1 gram. Then I start my setup. The thing about dimensional analysis is it's easy if you look at your unit of measurement in your denominator. That guides you to what's going to go in your numerator. Because remember, in dimensional analysis, you want to cancel out all units of measurement except for the one that you're looking for. So if we have gram in the denominator, we need gram in the numerator in order to cancel out. So now we go to our order, 400 milligram. 400 milligrams, but we need gram in our problem. So this is where our conversions come into play here. Now, dimensional analysis, you do have to remember your conversions, but we can do that, right? We can remember conversions, especially this one is 1 gram. 1 gram equals 1,000 milligrams. Remember that, and 1 milligram equals 1,000 mics. So that's one that is common conversion to use. So the good thing about dimensional analysis too is that you plug those conversions right into your problem. So 1 gram is to what? 1,000 milligrams. We put that right into our problem. Then we can pull milligrams out of our problem. He ordered 400 milligrams IM. So 400 milligrams. Now, let's see, we've canceled out grams, we canceled out milligrams, and we have milliliters left. Now we can solve, and you just multiply straight across. Remember, if you need to put a 1 here, you can do that. We don't stress out about those kind of things. 10 times 400 is 4,000. And 1 times 1,000 times 1 is 1,000. And we're going to divide that out. 4,000 divided by 1,000. Yes, da 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 da. You guys got it. 4. 4 milliliters. Right? Milliliters was our only unit left. You carry all of that over just so you can see how your milliliters follow through your problem. So 4 milliliters is our answer. And again, that's the basis of dimensional analysis. Just setting up your problem, getting what you need from your problem. If you have to convert, plug those conversions right into your problem. Moving on. A child who weighs 48 pounds is prescribed azithromycin 10 milligrams per kilogram PO daily times 3 days to treat bacterial sinusitis. Azithromycin oral suspension is available in 15, 22, and 30 milliliter bottles containing 200 milligrams per 5 milliliter. How many milliliters will the nurse administer? Now, I tell you, these type of questions are on your nursing exams. They may be on NCLEX. They give you a lot of numbers. They throw in numbers in there. They give you other information. But stay the course. Stay the course. Keep your same system up. Look for what are you looking for here? What is the question asking you? How many milliliters? That's what we're going to start with, milliliters. Milliliters equals, what do we have available? We have 200, sure I'm on my pen, 200 milligrams per 5 milliliters. Now this other stuff in here, talking about you have available 15, 22, and 30 milliliter bottles. That's all fine and dandy, but that's not what we're looking for. We're looking for that dose, that concentration. So don't be thrown off by other numbers that they put in the problem. So we're going to plug in our 5 milliliters to 200 milligram. All right, we have milligram in our denominator. We're looking for milligram in our problem. What did they order? 10 milligrams per kilogram. Now, 10 milligrams per kilogram presents another challenge here. We won't say problem, challenge. But the good thing about dimensional analysis is you plug all your conversions, whatever you need, you plug it right into your problem, your setup here. So we need milligrams. We can put our 10 milligrams here per kilogram. Now we have kilogram in our denominator. We need kilogram in our numerator, right? Do we have kilograms in here? What are we really trying to look for here? This dose, right? We're trying to look for this 10 milligram per kilogram dose because this child weighs 48 pounds. So we have to do our conversions with kilograms and pounds. Therefore, we can plug in our 1 kilogram because remember 1 kilogram equals how many pounds? 2.2 pounds. 1 kilogram equals 2.2 pounds. So we plug that right into our problem. 2.2 pounds. Then that cancels out our kilograms, our milligrams we've already canceled. We still have pounds hanging in here, but we're gonna plug our child's weight right into problem. Right? If you need to put a 1 there, you can. Now our pounds can cancel out. And we're still left with our milliliters, right? And that's what we're looking for. So now we can solve. And we just do our 5 times 10 times 48 is 2400. And 200 times 2.2 is 440. Oops. See, 440. Right. So we keep on dividing that out. 2400 divided by 440 is really you get 5.4545, right? But you always want to just round to the nearest tenth. So when you round to the nearest tenth, you will get 5.5, and that's going to be milliliters. 5.5, right? We're rounding to the nearest tenth, so that means we're looking at this 5 or more, you go up 1, and that's how we get our 5.5. 5.5 milliliters. Now, you can plug in your pounds. If you want to say, you know what, I don't want to deal with plugging in that conversion, I'll just figure out what my dose is for my child who weighs 48 pounds. It's 10 milligram per kilogram. You can still do that too. You can still take your 48 pounds, 48 divided by 2.2. So 48 divided by 2.2 is 21.8. 21.8 kilograms. Now, what if you say, I don't remember how to convert pounds to kilograms and kilograms to pounds? Do you multiply? Do you divide? What do you do? Well, you can still use dimensional analysis for that. Let's just see if we start over this problem. I'm going to erase here. And let's just say you didn't know really how to get pounds and kilograms, you know, so that's clear for you. Let's just say you didn't know how to do that. So you can just say, well, ask yourself, what am I looking for? I'm looking for kilogram. So you can say kilogram equals what? 1 kilogram is 2.2 pounds. You got your pound in your denominator, put your pounds in your numerator for 48 pounds. And you need to put a 1 there, you can. And you're still going to get your 48 divided by 2.2. So it's still going to get you there, 21.8 kilograms. Okay, so you can still use dimensional analysis to get you to where you need to be. Now let's just say, hey, I didn't want to, how we did it the first time, I didn't want to plug in the conversion for kilograms and pounds. I wanted to just divide my 48 times 2.2, get my 21.8 kilogram. How do I plug that into the problem? It's basically the same thing. Let's erase this. You can do whatever works for you. Whatever you understand, whatever you work however you work the best, whatever you remember that you know is right, then that's what you do. Let's just say we didn't want to plug in conversions for kilograms and pounds. We just said, you know what, I know, take my 48, divide it by 2.2. Remember that was pound, kilogram. Divide it and get my dose, my dose. 48 divided by 2.2, 21.8. So I got it. So I'll just leave that to the side and I'll set up my problem. My problem is, remember, looking for milliliters. Milliliters. Oops. Go back to my pen. Looking for milliliters. So milliliters. Remember, we disregard the size of the bottles don't matter. We're looking at the concentration. 5 milliliter, 200 milligram. Right? Then we're going to go to our dose. 10 milligram per 1 kilogram. Right? That's where we were there. 10 milligram per 1 kilogram. Now we got to make it specific to this child, but we did our conversion up here. So we'll just plug in our kilograms, 21.8 kilogram. If you need to put a 1 there, put it there. And let's multiply. 5 times 10 is 50. times 21.8 is 1090. 200 times 1 is 200. Let's divide that out. 1090 divided by 200 is 5.45, which you round to the nearest tenth or whatever it tells you to round. If it tells you something different, round to that. But if you need to round and it doesn't tell you, round to the nearest tenth. And that's going to get you 5.5 milliliters. So you still come out with the correct answer. That's the good thing about dimensional analysis. It's great. So let it keep on working these problems. A 125-pound patient is to receive a single IV dose of ondansetron, 0.15 milligram per kilogram. Ondansetron is available in a 20 milliliter multi-dose vial of 2 milligram per milliliter. How many milliliters will the nurse administer? Well, hey, what do? We go right into asking what is it looking for? Milliliters. We're going to start with milliliters. What do we have available? Remember, don't let them trick you up with this. It's available in a 20 milliliter vial because we're looking at the concentration here. That's what we need. So we are going from 1 milliliter to 2 milligram. We are going to look for a milligram in our order here. 0.15 milligram per kilogram. And remember, this is another one that has a weight in here. So you can do however you want to do. You can plug it right in your weight. You can figure out what that is in kilograms. That 125 pounds, you can figure that out. Or you can just work it all out however you want to do. Okay? So 1 kilogram to 2.2 pounds. And then what is our pound? 125 pounds. That cancels everything out. We're left with milliliters, and then we just multiply 0.15 times 125 is 18.75. 18.75, and then 2 times 2.2. Oops. 4.4. We divide that out. 18.75 divided by 4.4 equals 4.26. When we round to the nearest tenth, 4.3 milliliter. 4.3 milliliter. And there you have it. Simple as that. Moving right along. The order is 500 mics IV. On hand, you have a 2 milliliter vial containing 1 milligram per milliliter. How many milliliters will the nurse administer? How many milliliters? Looking for milliliters. We're going to plug what we have right in. 1 milliliter to 1 milligram. What do we have on hand? I'm not on hand. What do we have ordered? 500 mics. Again, we need milligrams, right? We know our conversions, and 1 milligram equals 1,000 mics. So we plug that right in. 1 milligram equals 1,000 mics. Now we can plug in our 500 mics, right? Mics cancel, milligrams cancel. We can multiply. 500, 1 times 1,000 is 1,000. 500 divided by 1,000 equals 0.5 milliliters. 0.5 milliliters. That's it. You all leave in a comment what you think about dimensional analysis, or oh yes, this is going to be a good one because we had per day. This next problem, it's asking per day, but then it turns around and we think about per dose. We'll do the same problem showing solving for different things. It just goes to show that dimensional analysis, it doesn't matter what they're asking you for. If they're asking you for milliliters or tablets or dose or per day or whatever, you can plug it in and you can solve for it. So let's read this one. The nurse practitioner, let's see, get on my pen. The nurse practitioner has ordered 100 milligrams BID of a drug which is available in 5 milliliter vials labeled 50 milligram per milliliter. How many milliliters will you administer per day? How many milliliters per day? That's what it's asking. Milliliters per day. We can do this, y'all. Milliliters per day. We still gonna go in and get our information. We're starting with milliliters. So 1 milliliter. Get my pen. 1 milliliter to 50 milligram. Ordered is 100 milligram. BID. So 100 milligram, 12 hours. Right? BID twice a day. It's 24 hours in a day. So 24 hours in a day. 24 hours in one day. If they want to know per day, we cancel out milligrams, we cancel out hours, we have milliliters per day left, right? All right, let's multiply. 1 times 100 is 100, and 100 times 24 is 2,400. And then 50 times 12 is 600. Let's divide that out. 2,400 divided by 600 is 4. Right? And that was milliliters per day. So 4 milliliters per day. I could have wrote that a little bit. A little bit. Let's see. Clean that up. That's a tad. So you can actually read it. 4 milliliters. Okay. 4 milliliters per day. Now, what if they said per dose? We're going to take the same problem. The same problem. The nurse practitioner has ordered 100 milligrams BID of a drug which is available in 5 milliliter vials labeled 50 milligram per milliliter. How many milliliters will you administer per dose? Okay, per dose. We did per day. So this one is asking per dose, which is the same as just asking how many milliliters, right? Um, how many milliliters? But you, if you want to plug it in, say that you still can milliliters per dose. You still plug in what you have available. That concentration, not the size of the vial. 1 milliliter to 50 milligrams. And you still have 100 milligrams, right? In your order, 100 milligrams per dose. Milligrams canceled out. And you got milliliters per dose here. That's what we're looking for. So 1 times 100 is 100. And 50 times 1 is 50. 100 divided by 50 is, oops, this thing be jumping on me, y'all. 2 milliliters. So that's per dose. Same problem. We did the same problem. Remember? Same problem. Just plug in different information. Depends on what they're asking you for. And that's the good thing with dimensional analysis. Is they can ask you for whatever. This one is asking how many tablets will the nurse administer. You want to know how many tablets, right? How many tablets? So let's start with tabs. How many tablets? So what do we have? We have 125 mic score tablets. So we was asking about tabs. I'm gonna start with tab. One tab is what? 125 mics. 125 mics. Let's get mics in our denominator, mics in our numerator. Right? In our order, we have milligrams. What do we know? We know 1 gram equals 1,000 milligrams. And we know 1 milligram equals 1,000 mics. All right, we're going to plug it right in. 1,000 mics is to 1 milligram. And now we're going to plug in our order here, 0.25 milligram. You need to put a 1 there, put it there, and then multiply. 1,000 times 0.25 equals 250. Y'all, I keep pushing this thing. It's 250. And then 125 times 1 times 1, 125. All right, 250 divided by 125 is 2. 2 what? Halves. That's why I usually carry, I say don't forget to write what you have here. That way you can stay straight. You don't forget what you're even solving for. Tab. So 2 tabs. And there you have it. Plugged in, good to go with the correct answer. That was it, you guys. So you guys have a good day. Let me know if you want to do more dimensional analysis problems. I'll have some more coming, I'm sure. I'll have some more NCLEX questions coming up for sure. And that's it for now. I'll see you guys next time.